Okay, welcome to Let's Get to the Marks. We're going through AQA Chemistry A Level, Group 7, the halogens. This is a multiple choice question pack. Make sure you pause the video and have a go. Which pair of solutions, when mixed, reacts to form a dark brown solution? Oh my gosh, check out my underlining. Awesome. Okay, so we're looking at which pair of solutions is going to give us a dark brown solution in the products. All right, let's get into it. Look at the first one, sodium fluoride aqueous plus chlorine. What do we know? Well, we know that fluorine is more reactive than chlorine, all right, because the halogens are more reactive at the top of the group and less reactive at the bottom. So there's no way that that chlorine aqueous can displace the fluoride from the sodium fluoride. What about is chlorine? Well, chlorine in the second one is more reactive than bromine. So again, we're not going to get a reaction. The bromine cannot displace chlorine from sodium chloride. And here we do have a reaction because we've got chlorine displacing bromine from sodium bromide, because chlorine is higher up the group than bromine. However, what is the color of a bromine solution? It's not dark brown, it's orange. Bromine's a red liquid, but in solution, it's orange. And here at the bottom, bromine is more reactive than iodine because iodine's lower down. So we get the reaction sodium iodide plus bromine equals sodium bromide plus iodine solution, iodine aqueous. And what color is iodine when it's in solution? That's right, folks. Iodine is brown in solution. Those of you that do biology, you know the color of iodine. Let's go. So the correct answer here for question one is D. Just make sure you pause the video because I don't want to keep saying it every single time. Pause the video, but just make sure you pause the video before you have a go at each question. Otherwise, I'm going to try and speed through so you can get the most benefit out of your time. All right, let's get on to question two. Some solid sodium halides are reacted with concentrated sulfuric acid. Which solid sodium halide does not produce a sulfur containing gas as one of these products? So remember that as you go down group 7, the halide ions become better reducing agents. Okay, they're better at giving away their electrons and causing something else to be reduced. This is because they have more shielding as we go down the group. So like iodine has more shells, more shielding, less attraction to the outer electron. It's better at giving it away. Iodide, I should say. So chloride ions are not strong enough as a reducing agent to carry out a redox reaction. And so they form like sodium sulfate or sodium hydrogen sulfate. But you'll notice that the sulfur in sodium hydrogen sulfate or sodium sulfate, if we draw sulfuric acid here, which is going to react with each of these, you'll notice that the sulfur in sulfuric acid has a +6 oxidation state. Now, if it was to form sulfur dioxide, it would go down to a +4 oxidation state. So it's been reduced by gaining electrons. And if it formed hydrogen sulfide, like sodium acetate can do, it would go down to +2. But when you go from sulfuric acid to sodium hydrogen sulfate, you don't actually get reduced. So sodium chloride is not a strong enough reducing agent to do a redox reaction. And that is the answer. Right, let's look at question 3. All right, question 3. Which properties increase down group 7? So the ability to oxidize a given reducing agent, the boiling point, the electronegativity, or the first ionization energy. We could go through all of these, but it's pretty simple. Just remember your state symbols for the halogens. Fluorine's a gas, chlorine's a gas, bromine's a red liquid, and iodine is a black-grey solid. So which one's going to have the highest boiling point and melting point? Well, that is going to be iodine out of those four. So yes, boiling point does increase down group 7, and that's the answer. Let's roll, people. We're going on to question 4. I believe there's 18 or 19 questions in this pack. Stick with it. By the end of it, you'll feel very confident on your ability to do questions on the halogens. Question 4. Which equation shows a redox reaction that does not occur? So we're looking for like a displacement reaction that can't happen. Now, how do displacement reactions work? You should remember that the more reactive halogen will push the less reactive halogen, which will be a halide ion, out of its compound. Okay, so more reactive halogen is going to push the less reactive one out. So let's have a look at these and see which one can occur. So look at the first one. Can bromine remove iodide ions? Yes, it can. And so that's not our correct answer. Is chlorine more reactive than iodine? Yes, so it will push out iodine from potassium iodide. We get right down to the bottom one and we find that iodine is too unreactive. It can't displace bromine from potassium bromide. And as this is the reaction that will not occur, that's the correct answer. Right, question 5. Which of these show the major products formed when chlorine reacts with dilute or cold dilute aqueous sodium hydroxide? So you're looking for a reaction with chlorine plus sodium hydroxide. So let's write out the reaction. We've got sodium hydroxide plus chlorine goes to sodium chlorate and sodium chloride. So the answer here is C. And we get some H2O as well. There's your reaction. So the answer is C. Just balance it up there. Bada bada bing. Yeah, that looks balanced. All right, let's move on. Question 6. We're going to be looking at what is the best oxidizing agent? Another one of these questions where we look at a combination of halogens and halide ions, and we're asked what is the best oxidizing agent. So what we have to ask ourselves, what does the term oxidizing agent actually mean? And you should remember from GCSE oil rig. Oxidation is loss, reduction is gain. Some people did Leo, grrr, like Leo the lion. So, yeah, loss of electrons for Leo. Yeah, you got it. Reduction is gain. Grrr, gain is reduction. So the two ways of remembering it: oil rig or Leo the light or Leo grrr. So oxidizing agents are themselves getting reduced, so they're gaining electrons. Could a fluoride ion with a full outer shell gain an electron? No, it can't. It's got no room to take any more electrons, so it's going to be a really rubbish oxidizing agent. And iodide ions also are going to be really rubbish as an oxidizing agent. They've got a full outer shell, so they're not going to be taking any more. So we're looking now at a choice between fluorine and iodine. And what's the difference between fluorine and iodine? Well, we know fluorine's more reactive, so that could probably give you a little hint as to which is the best oxidizing agent. And the reason is iodine, sorry, has more shells, so more shielding. The outer electrons are further from the nucleus, so less attracted to the nucleus. And what does that mean? Um, Fluorine is going to be the best at taking electrons because it has less shielding and that electron is closer to the nucleus. So fluorine is the best oxidizing agent. It's the best at getting reduced and making something else get oxidized by stealing the electron. So the answer is fluorine. And you could have just gone fluorine's more reactive. And there we go. Well, let's check out question 7. Which statement is correct about reactions involving halide ions? So this is like a word form of the ones we've looked at. So A, sodium chloride reacts with chlorine when added to concentrated sulfuric acid. Again, this is looking at the way the different halogens react. So sodium chloride ions aren't good enough at reducing sulfuric acid. They definitely can't reduce it to the point where they form chlorine. They form hydrogen chloride. Sodium chloride forms chlorine when added to bromine. Well, sodium chloride forms chlorine when added. Well, bromine cannot displace. Bromine's less reactive, so it can't displace the chlorine. So we know that's not true. And then C, solid sodium bromide forms bromine when added to concentrated sulfuric acid. And then we've got D, solid bromide forms bromine when added to iodine. Well, we know that iodine is less reactive than bromine. There's no way iodine can displace bromine from sodium bromide. So we know that D is incorrect. Now, if we look at C, you have to know your reactions of the halide ions. And the halide ions, that means a halogen which has gained an electron, they get better reducing agents as you go down the group. Now, sodium chloride is actually not strong, or chloride ions are not strong enough a reducing agent to form chlorine. They form hydrogen chloride with sulfuric acid. Whereas sodium bromide, you need to know this reaction off by heart. When sodium bromide reacts with sulfuric acid, it's going to form sodium hydrogen sulfate, or you can say sodium sulfate, Na2SO4, and it's going to form hydrogen bromide. And that is the first step of the reaction, and that is not a redox reaction. But then it has a second reaction where hydrogen bromide reacts with excess sulfuric acid, and it's there that we get the bromine released. Okay, question 8. An aqueous solution of salt gives a white precipitate when mixed with aqueous silver nitrate and when mixed with dilute sulfuric acid, which could be the formula of the salt. So what we're looking at here, we've got barium chloride, we've got ammonium sulfate, potassium chloride, and strontium nitrate. Which of these could be the salt? Well, think about it. Think about your halide test. If you mix chloride ions with silver ions in the silver nitrate test, you get silver chloride, and that's a white solid or a white precipitate. So we're looking for something with chloride ions. So our answer has to either be A or C. Now, it also tells us that when we mix with sulfuric acid, we get a white precipitate. And you know the test for sulfates or sulfate ions that you find in sulfuric acid is the barium chloride test. So if you have barium chloride, you get barium plus sulfate ions makes a white insoluble precipitate of barium sulfate. Remember, we use that in medical imaging, the barium sulfate. And so our answer here is A. Question 9. Which statement is not correct about the trends in the properties of hydrogen halides going from HCl to HI? So we're not really including HF here. So as we go down, do the boiling points decrease? Does the bond dissociation energy of HX decrease? So this is about how well do they dissolve in water? How much does it take those H2O molecules to dissociate that bond? Does the polarity of the HX bond decrease? Are they more easily oxidized in aqueous solutions? Well, let's check out the boiling points. The boiling points, you do need to know this pattern. So hydrogen fluoride has the highest boiling point, but then we get a general increase in boiling point as we go down the group. And why is that? Well, the molecules get bigger. So HI is bigger than HCl, and we have increasing size, increasing number of electrons. So we get increasing van der Waals forces. So stronger intermolecular forces. So HI is stronger. Hydrogen fluoride is the exception and has the highest boiling point of all the hydrogen halides. And that's because, of course, hydrogen fluoride is one of the rare molecules that can do hydrogen bonding. So it has that as well as van der Waals forces. So that's why it's an exception. If we actually look at the polarity of the bond, the more electronegative you are, the more polar your bond will be. We can see here that the chloride ion is the most electronegative out of those, so that's the correct answer. Remember, the top right of the periodic table, chlorine's pretty high up, and pretty much to the right means more electronegative. Obviously, as we go down the group, they become less electronegative, and so their ability to polarize bonds decreases as we go down the group. Okay, question 10. What is the most suitable reagent for detecting the presence of carbonate ions in the presence of excess sulfate ions? So, if you've got carbonate ions, what's the easiest way to detect that you're dealing with something like calcium carbonate, magnesium carbonate, or something like that? Well, you should notice from GCSE, you can add sulfuric acid, and that is going to, you could add hydrochloric acid, but we can add sulfuric acid here, and that's going to form carbon dioxide as a product, which we can then do the lime water test, and that will allow us to know that there were carbonate ions present. Which statement is correct about the reaction between concentrated sulfuric acid and solid sodium bromide? We come back to this one again. So you want your NaBr plus H2SO4, write it out, write the reaction out, and then you can check which one's the correct answer. So with sodium bromide, you get a two reaction process going on with sulfuric acid. We have NaBr plus sulfuric acid makes sodium hydrogen sulfate, or the hydrogen halide hydrogen bromide. And then because bromide is a better reducing agent than chloride, we get a second reaction, which is hydrogen bromide re-reacts with the sulfuric acid. And now it can form bromine. And we also get a sulfur containing gas, which is sulfur dioxide and water. You do not get hydrogen sulfide with bromide ions. They're not that much of a reducing agent. They can't reduce the sulfur to less than +4. Okay. If we had iodine or iodide ions, we would be able to reduce the sulfur to form hydrogen sulfide. So just as a reminder, the first reaction in the reactions of any hydrogen halide with sulfuric acid is not a reduction reaction, But the second reaction, when the hydrogen halide reacts, the hydrogen halide formed in the first reaction reacts with the sulfuric acid in the second, that is a redox reaction. As you'll see, bromine loses its electron, or bromide, sorry, from hydrogen bromide loses its electron and becomes bromine with an oxidation state of 0 in its elemental state. And the sulfur in the sulfuric acid goes from a +6 oxidation state to a +4 oxidation state. So it gains those electrons that the bromide lost. So are bromide ions reduced? No, bromide ions do not get reduced. They lose their electrons, so they're oxidized. Is hydrogen bromide and sulfur formed? No, we don't get sulfur formed. We get sulfur dioxide formed. It's not a strong enough reducing agent to reduce the sulfuric acid to sulfur. You'd need iodide ions for that. Sulfuric acid acts as an oxidizing agent. Well, the sulfuric acid, as we said, it goes from +4 and it goes to, sorry, it goes from +6 to +4. What does that mean? That means it's gained electrons, it's caused something to be oxidized. So yes, H2SO4 in these reactions acts as an oxidizing agent by taking electrons and being itself produced. The sulfur in the sulfuric acid gets reduced, so the sulfuric acid is acting as an oxidizing agent. And for D, bromine and hydrogen sulfide are formed. Bromine is formed, but again, hydrogen sulfide, the sulfur would need to be reduced to a +2 charge, and that's not possible by the bromide ions. They're not strong enough producing agents to do that. So D would not be the correct answer. Okay, question 12. Which is the best technique to remove silver chloride that forms when aqueous solutions of silver nitrate and sodium chloride react? So what you're going to get here, you're going to get sodium nitrate as a side product, and you're going to get silver chloride. So what you can do is you can filter out, you can use filtration, because the sodium nitrate is soluble, will go through the filter paper, and the silver chloride is a solid white precipitate, and so will not go through the filter paper. So this is the best method for separating them. Let's look at question 13. Which statement about astatine is correct? Astatine has a greater electronegativity than bromine. What did we say about the electronegativity of the halogens? So as we go down the group from fluorine, which is probably the most electronegative element in the periodic table, remember electronegativity increases to the top right of the periodic table. We can't count the noble gases, so fluorine is the most top right element you can get, except for the noble gases. So that's the most electronegative. And as we go down the group to astatine, it's going to get less electronegative. So A is definitely wrong. Astatine's better oxidizing agent than bromine. Well, no, as we go down the group, they get less reactive. Why do they get less reactive? Remember, there's more shielding, the electrons further from the nucleus, so it's not going to be better at oxidizing. Astatine is a greater boiling point than bromine. Let's remember the state symbols. Bromine is a red liquid, iodine is a black solid, astatine, we can presume, is also a dark solid. So our correct answer here is C. Okay, which species is not produced by a redox reaction between solid sodium iodide and concentrated sulfuric acid? So again, here we need to know these reactions off by heart. You need to know the reactions of the different halide ions, or the different sodium halides with sulfuric acid. So it's the same as saying a halide ion, like how do iodide ions react with sulfuric acid? In AQA, we put them in the form of like sodium iodide, sodium chloride, sodium bromide, etc. So you need to know this. Iodide ions are the best reducing agent out of the chloride, bromide, and iodide ions. Iodide ions can reduce the sulfur in the sulfuric acid the furthest. So the first reaction, the sodium iodide reacts with the sulfuric acid. It's not a redox reaction. It forms hydrogen iodide and sodium hydrogen sulfate, or sodium sulfate. In the second reaction, the hydrogen iodide ions that were produced in the first reaction go and react with some more sulfuric acid, and this time enough of a redox reaction happens for the sulfur in the sulfuric acid to be reduced to sulfur dioxide, which is a sulfur containing gas, and we get iodine formed. And then there is another reaction where the hydrogen iodide ions further react with sulfuric acid, forming solid black iodine and some solid sulfur and water. And then we also have a reaction, you can combine these last two. We also have a reaction where the hydrogen iodide reacts with sulfuric acid and we get the sulfur containing gas, the smelly one, hydrogen sulfide formed, and more water as well. So which of these species is not made in a redox reaction? Well, that's anything in the top reaction, because the top one of these four reactions is not a redox. And I'll just show you why these are all redox. So in the first one here, in the second reaction, sorry, the sulfur gains 2 electrons, so is reduced from +6 to +4. In the second reaction, the sulfur goes from +6 to 0. So that's reduction again, as you're gaining 6 electrons. And then in the last reaction here, we've got it gaining 4 electrons. So all of these are reduction. However, that first reaction, you can see the sulfur is at +6, and then in sodium hydrogen sulfonate, or in answer A, the sulfur is still +6. So there has been no redox reaction taking place in the reaction A. So what can we say about the answers here? A, B, C, and D. We can say that A, and by the way, sodium hydrogen sulfonate, sulfate is formed, or sodium sulfate is formed, Na2SO4. So this is formed, this Na2SO4 is formed in a reaction with sulfuric acid and sodium iodide, and it is not a redox reaction. God, that took a while for me to say that. Okay, let's move on to question 15. Question 15, which equation represents a reaction that does take place? Well, have a look here. Chlorine reacts with sodium iodide. Does it push out the iodine? Well, we know that chlorine is more reactive than iodine because it's higher up the group, and therefore it can displace the iodine from sodium iodide. So yes, this first reaction takes place, and that's your answer. No need to bother looking at the others. Question 16, which species is the best oxidizing agent? Once again, what do we mean by oxidizing agent? We mean which one of these answers, which species here, which chemical, compound, ion, atom, element, which one of these wants to take electrons, get itself reduced, and cause something else to lose electrons? We can see bromide ions, chloride ions, they can't take electrons off anything. They've already got a full outer shell. So negative ions tend not to be very good oxidizing agents because they already have a full shell. So to oxidize something, to take its electrons, you need to have space for electrons yourself. So A and B and D are not going to be the correct answer. So then it comes down to, is chlorine or bromine better at stealing electrons? And of course, chlorine is the better oxidizing agent. Why? It's more reactive. It has less shielding, and the electron is closer to the nucleus, so feels the attraction more. So it's easier for chlorine to take an electron and oxidize something. And here we go. Which statement is not correct about the addition of chlorine to water? So let's have a look at the equation. If you add chlorine to H2O, you're going to make hydrogen chlorate or chlorate ions, ClO minus, or you can write HClO. And you're going to make hydrogen chloride. So which of these is not correct? Well, the bottom one, chlorine can react with water to produce chloride ions and chlorate ions. Yep, we got that right above there. You get chloride ions in the hydrogen chloride, and you've got chlorate ions in the ClO. Chlorine can kill bacteria. Yes, we know we add chlorine, it kills bacteria. Chlorine can react with water to produce chloride ions and oxygen. Yes, this is true too. In the presence of ultraviolet light or sunlight, it can basically do this reaction above. So there we go. Our answer has to be A. And the reason is chlorine reacts with water to form an alkaline solution. No, it doesn't. That's not correct. It forms two acids. And here we go. It's an unusual reaction. Okay, let's look at the next one. Which of these species is the best reducing agent? Okay, so in this situation, when you're a reducing agent, you need to lose electrons, you need to give those electrons away and make something else get reduced. And so the reducing agent itself is oxidized. So what we have to ask ourselves, can chlorine lose electrons? Reducing agents give away electrons. Chlorine is unlikely to give away electrons, and iodine is unlikely to give away electrons. They haven't stolen any electrons like iodide ions. So iodide ions have an electron that they can give away, right? So we'll show that as a cross here on the chlorine, and then on the iodine, we'll show that as a cross as well. Remember that iodine has more shells, so more shielding than chlorine. And this means that the gained electron, the X on the iodine, is further away from the nuclear charge and therefore easier to give away. Therefore, the iodide ions, as what we're showing here, are the better reducing agents. All right, last question. And that means the carbon halide bond that's the easiest to break apart will be the one that most rapidly forms a precipitate with silver nitrate because it forms the halide ions which react with the Ag+. And what we'll find is that the iodine carbon bond has the weakest bond enthalpy, the lowest amount of energy needed to break that bond, so it reacts the fastest of all these haloalkanes. Awesome. Of course, that's saying if all the conditions are kept the same. All right, guys, hope you enjoyed. Subscribe. Let's get to the
You're
mark.
still here? It's over.